So this month's presentation is one that Eric has done a few times for brewing water. So we will have Eric start his presentation, and it's all about making, as you see there on screen, make great beer by adjusting your brewing water. So take it away, Eric.
Thanks, Dave. I'm just trying to pull up the chat window, so if anything comes in, I have a chance of at least seeing it. But if anyone has questions, I'm open for interruptions, but try not to make the whole presentation interruptions, and I'll be happy. But I'm happy to take questions along the way. The way this presentation gets better is every year someone asks some questions, and I realized I probably should have mentioned that. So I tried to do minor updates this year. I think a lot of you have probably seen this presentation before. The last time I did it was January 2020. Last year we had John Palmer present. I think he presented in November, and then in November 2020. And then I was told, okay, maybe Eric, you shouldn't do your water presentation in January 2021. So it's been 2 years, though I haven't really changed much. But I think there's probably still at least 50% of you who haven't seen this, maybe even 75% of you who haven't seen this. So I hope it's a good way to present brewing water. I know when I started homebrewing, this was one of the most intimidating topics, and it probably still is for a lot of people. This presentation is mainly intended to be like an introduction level. I'm trying not to go too deep into any one topic that make your eyes glaze over. So I hope I achieved that. And yeah, so I'll take your questions anytime. Just try to keep them on topic. Okay, so click. There we go. Okay, so every year I've always had a link, a screenshot of what our past presentations page looks like. I noticed that the last presentation that's been posted was July 2021. So I put a little hint, David Chang Sang here to remind you to update the page of past presentations. Hint, hint. I guess that's more than a hint since I said it. Okay, all right, so topics covered. Sorry, David.
Way to call him out in front of everyone, Eric.
Yeah, more than a hint, it's a call out.
That's okay. I'll have to look and get it updated.
How about we change that phrasing to a public shaming?
Yeah.
Put it on me, Eric. I'm the president. It's I'm accountable for it.
Okay, I'm going to change that slide right now to David L. But yeah, I like that page has almost every presentation that's ever been done. So I think it's a really handy page if anyone's curious to know what's been presented before. If you want to know, if you have ideas, or if you want to look at the kind of topics that people present and maybe help propose ideas as well, it helps our meetings become interesting. All right, so the topics in this presentation and how I broke it up. So does water chemistry matter? The tools needed to do this, removing chlorine, intro to brewing minerals, water sources, intro to mash pH, residual alkalinity, and then my approach on all this, and then a few examples to wrap it up. Okay, so does water chemistry matter? Yes, but it's only going to make your good beer great. It's not going to make your not very good beer good beer. So to do that, to make good beer first, fermentation and yeast health, packaging and sanitation. Those are some of the most important things that you can do to make good beer. And whenever someone asks me if water chemistry matters, I say, well, water is 95% of the ingredients in your beverage. So how can it not matter? And that's of course assuming like a 5% beer. Maybe if you're doing 20% alcohol, crazy monsters, maybe the water isn't quite as important. Yeah, so water chemistry, it influences the flavor expression and how certain yeasts express their characteristics. And I haven't read a brewlosophy experiment in a few years, but back when I was putting this presentation together over the first few times, every time there was a new brewing water experiment that came out, out of like they were like maybe 1 out of 10 experiments, but they were also quite often the 1 out of 10 experiments that came back significant. So yeah. So does water chemistry matter?
A bag of Lindors and a full box of chocolates, but the Lindor is probably your best luck for maybe white
David,
chocolate.
can we mute that? Okay. All right, so does water chemistry matter? So water chemistry is a pretty vague term. People aren't really sure what it means. So I try to break it down into 2 things: mash pH adjustment and mineral concentration adjustment. So there's two big pieces of water chemistry, and they're a little bit more specific, so maybe the term is a little less vague. All right, so tools needed. So every year I update this slide with the latest recommended pH meters. I know that's always the first tool that people look at getting. So I recommend getting a reliable brand with a track record and that has affordable and available probes. And I also recommend looking for one with at least 0.05 pH accuracy and then 0.01 resolution. The pH meter that I'm currently using is the pH 56. It seems that on Amazon, it's actually more expensive currently than local homebrew stores. So there's never been a better reason to go shop at the Homebrew Beer Academy if you're trying to get a pH meter, because apparently they're $15 cheaper than Amazon, which is crazy. So go check out Homebrew Academy if you want to get one of these pH 56. The probes are generally available pretty well in Canada, and you're looking for the MI 56P. And that's I think I have a picture of that meter on the next slide. If you're looking to go a little bit more pro with a little bit more accuracy, the MW 102 is the next step up from that. Probably a little bit more of a pro spin on it, but the probes are still somewhat available. I had the ThermoWorks pH meter on here for several years, and a bunch of people bought it, and then we started getting a bunch of negative feedback about people having it not go slide into the correct pH range very quickly, or even just not calibrate very well at all. I know several folks went through support trying to get it fixed and had not very great luck and switched over to the Milwaukee pH 56. So I took that off this year, and I wanted to just call it that I took it off so folks are aware that I didn't omit it by ignorance. But the pH 56 is fantastic. I really like it. I see a question about probe lifespan. Perhaps that is something I should include on here. I try to replace my probe every year if I'm brewing pretty regularly. They're about $60. I think maybe that was when I was brewing 30 times a year. I don't brew that often anymore. I'll probably I'll probably fall into a 2-year cycle now. Yeah, if you can, once a year is probably way more than recommended. I also see a question about probe storage. So I guess I also don't think I have anything about that on here. Oops, I did not mean to click that link. I'm just going to go back to presentation mode. Yeah, so I try to store it with a storage solution that you can buy through the bulk buys, but you can also use the 4.0 pH buffer that I think I have on one of these next slides. But you can also use the 4.0 pH buffer for storage if you don't want to buy storage solution. So one important point, if you're going to use a pH meter, don't bother unless you're going to calibrate it every brew day. So our bulk buys have these bulk boxes of pH packets. Those are really convenient because once you open a pH buffer solution, the shelf life starts to go of a couple months. But if you're buying individual packets, then there's no shelf life because you open it, measure, then toss. One pair of those boxes usually lasts me like 1.5 years. All right, so I put a little picture here to show. Oh, this is my old meter. There you go. So I hadn't updated this slide. But this is a meter I used to recommend called the Omega. It got really expensive. I think it's just now the price of like the Milwaukee 102, even though it's a little handheld pen. But I think a lot of folks still have it, and it still works pretty good. But some of the other tools you can kind of see here in my little pH measuring setup. You see, I have a little ice bath and a stainless steel cup. That's one of the tricks that I try to share with people. When you take a pH measurement, you want to make sure that you're doing it at room temp, because all the literature is written when they tell you a pH to put your beer at, that's in reference to room temp. And I think I have something on here about ATC, or maybe not. Oh, here you go, metal cup. Yeah, so I'm getting ahead of myself. So other tools that are needed: Camden tablets for removing chlorine, an accurate scale. If you're going to measure salts, you want one with 0.01 gram resolution. I think that's really good because that way you can actually trust that first point digit. These scales are cheap; they're like under $20. So I find that if I have an extra digit, I can actually trust the slightly more significant one. This is the one I recommend, but though there's lots of different versions of a similar thing on Amazon. If you want some salts and acid, lactic acid 88%, gypsum and calcium chloride, you want both of those. That metal cup that I showed on the last slide, being used to cool down pH samples to room temp. And I was reading the slide earlier today, trying to prepare. And I thought to myself, when was the last time I heard anyone mention pH 5.2 stabilizer? When I started homebrewing, this used to be all the rage. 5-Star had this product out called 5.2, and they advertised it as a way to just throw this in your beer and it'll be perfectly 5.2 every time. People used to talk about that all the time. They say, "Oh, I don't bother with water chemistry. I just use 5.2." And and now I don't hear about that anymore at all, thankfully. I think a couple of years after I started homebrewing, the truth came out, or story, I don't know if it was really the truth, about how that product was formulated for one specific brewery with their specific water, so it worked for them. But then they released it as a general product, and then people just kind of took it too far. I also do not recommend you use pH strips. The resolution and color matching on that just makes it a kind of useless tool. It's great for pool water, but not great for brewing. All right, so I mentioned ATC, which I think I should probably add on this slide, or maybe the pH meter slide at one point. But I get asked a lot about, why do I need to cool this down to room temperature when my pH meter advertises that it has automatic temperature correction? So ATC functionality in pH meters is only useful for correcting the response of the probe at different temperatures. It doesn't actually correct the change in pH of your sample at different temperatures. So the actual physical pH of the wort is different at different temperatures, not just how the probe measures at different temperatures. So everything is written as a reference to room temperature, so that's what you have to measure at. Okay, all right, so chlorine. So removing chlorine.
We got a few questions, Eric, just
okay.
in the chat.
I missed a few, okay.
Joe's has when, and you might get to this later, but when and how many times do you measure pH during your typical brew day?
Okay,
is that coming up?
I don't think I have that. I can answer these ones quickly. So typically in my brew day, I will measure pH mostly once, maybe twice, maybe about 10 minutes after mashing. Take the sample, throw it in the ice bath to cool back down to room temperature, then measure it. If I have to make an adjustment, then I'll have to measure twice, because I'll measure again after the adjustment usually. Epsom salts, it's just not one that I typically use. But baking soda, I have started using somewhat in recent years if I'm trying to buffer against really acidic malt. I didn't really put that one in here since I didn't consider it like an entry level. But yeah, baking soda, totally. Epsom salts, not so much. I think it has magnesium in it. But if you want to go for it, I think you can go for it. Yeah, and Toronto water, like is a fair amount of bicarbonate. So the only time you need to add more is if you're making a really, really dark beer. Maybe in my super imperial stout, which is like 15 or 20% roasted malts, maybe, or maybe like a 30% crystal malt beer. I don't know, but generally you can get away without it in Toronto. And I think that's a big part of this presentation is this is water chemistry as you can do in Toronto without having. So this is using the characteristics of our water. Like if you go somewhere else, like Guelph, and you have everything has to go through like an ozone filter to RO it or something. That's a totally different process. All right, so chlorine. So chlorine and chloramine are two different chemicals that can be added to water by city water treatment, and they both create off flavors in your beer, so you want to remove them. And why do we add them in the first place? Well, it's to keep your tap water safe to drink, because contaminants, bacteria, algae, they can all grow or bloom in the water. Yeah. Can you speak? So I'll talk more about my adjustment process. I think I have a section just for that, so I'll get to that one. So chlorine. So these compounds react with yeast-derived phenols to form chlorophenol. So if you're not sure what a chlorophenol smells or tastes like, it smells medicinal, a little bit like bleach or antiseptic mouthwash. So not great flavors, and it can tend to cover up a lot of other flavors in your beer if you have it. So the number one recommended method to get rid of chlorine and chloramine is Camden Tablets. It comes in both sodium and potassium versions of this, but I like the potassium ones so I'm not adding sodium to my beer. One tablet can treat up to 20 gallons of water. I got asked a lot over the years, well, how much sulfate am I adding? So I looked it up and it's about 9 ppm. Not enough to really adjust your recipe for, but if you're curious what's going on behind the scenes, it should be about 9 ppm. Removing chlorine. So activated carbon filtration, I get asked about this one all the time. So it is sort of useful if you want, because it does do something that Camden Tablets doesn't do, which is remove pesticides. But the rate at which you have to flow water through a carbon filter to remove chloramine is super slow, 0.125 milliliters liters per minute. So about 2.5 hours, 2.7 hours, 3 hours to filter enough for your beer. And that's just your batch size. If you're going to brew with 40 liters for a 23-liter batch, that's double that. So I would definitely not recommend only relying on carbon filtration to remove chloramine. Chlorine you can flow quite a bit faster, but Toronto uses chloramine, so keep that in mind. Yeah, so potassium Camden tablets. Normally what I do is I will not even measure the tablet. I'll throw it into my strike water, crush it a little bit if I feel like it, and then not even split it between strike and sparge. And I also I always round up to the nearest tablet. I'm not cutting tablets to 3/4 tablet because I'm doing a certain batch size. Yeah, find it much easier. All right, so I see a question about water profiles, but I have a section of water profiles, so I'll try and get back to it there. So intro to brewing minerals. So this section could be a little chemistry heavy if you have no chemistry background, but I try to keep it a little light. So most of these brewing minerals have a certain charge associated with them because that helps them pair up with each other. So calcium, magnesium, sodium are the positively charged ones, and bicarbonate, sulfate, and chloride are the negatively charged ones. So I tried to lay out here over the next 2 slides a little bit about what each one contributes to your beer. So calcium is the big one. It affects pretty much everything. It lowers your mash pH. It promotes the flocculation of your yeast and protein to clump together and helps create a clear beer. So perhaps your hazies don't help you. It also limits the extractions of tannins in your beer. So if you're trying to avoid having an astringent beer, calcium helps with that. Generally, if you want to add calcium, you're going to add either gypsum or calcium chloride. Those are the big two that pretty much everyone uses. So if you're adding calcium, usually you're adding one of those two. So sulfate. So this affects the perception of bitterness, helps give the beer a drier and crisper impression. So if you're reading some beginner texts that are really quite old, How to Brew doesn't say this, I don't think, but some of the older intro to homebrewing textbooks do. So this doesn't make your beer hoppier, but it may enhance the perception of hop bitterness. But it doesn't make your Galaxy hops taste even peachier or more stone fruity. Chloride then. So that's the other one that I mentioned is one of the big ones that you add when you add calcium. So it affects the perception of sweetness and body in your beer. So I do have a note about how if you are using calcium chloride, and I've never done this, but it does pick up moisture if you leave it exposed to air. So if you do leave it exposed to air and you start noticing an issue, you may have to dry it out in your oven to make it anhydrous, which just means pure, not clogged with water. Brew and Water recommends making a solution of a known concentration, and that way it doesn't pick up a bunch of water and kind of throw off your measurements. But all this to say, similar to how sulfate doesn't make your beer taste hoppier, chloride doesn't make your beer taste maltier, but it does affect the elements that people associate with malt, like sweetness and body. I had this question for Palmer, and he shrugged. What was your? Oh, should you just add it all in the beginning? I see. Okay. Okay, I'll get back. Your question's pretty long for me to read on the fly, right? And I'll get back to it. Okay, so brewing minerals. So sulfate and chloride, people talk about sulfate and chloride ratio. So that's kind of how people write this, SO4 with a colon and then Cl. So sulfate to chloride ratio does matter, but so does the seasoning level. So 50 to 100 is 2 to 1, or I guess 1 to 2. Is not the same thing as like 100 to 200. even though they're both 1 to 2. So just experiment to find your preference, play with your recipe. That's the fun of the hobby, right? To tweak your recipe every time to get it that little bit better, or maybe that little bit worse, so you know to go back. So bicarbonate is another brewing mineral, helps determine your alkalinity. And what does alkalinity do in your beer? It helps act as a buffering against acid additions to lower the pH. So I think we were talking about baking soda a little bit earlier. So that can be a way that you can have bicarbonate to help buffer against some acidic malts. Though we don't, I think we already have a good amount in Toronto, and you'd have to be using quite a lot of acidic malt to have it be worth it. Magnesium and sodium, generally, people don't adjust these, but you do track them to make sure they're in range. If you really want to play around, you can adjust them. I know some folks have played with sodium in dark beers, but generally, if you're just getting into this, I would recommend you try not to focus on them, just make sure they're okay. All right, so what ranges are okay? Calcium, there's pretty big ranges okay. I say 50 to 150. I think you can find fine brewing waters that are a little bit higher than that. Sulfate, 50 to 400. Though you go higher and higher, it becomes a little bit more harsh. I'm sure there's famous brewing waters out in the world that have even higher than this too. Chloride, I think I used to say 50 to like 100 or 50 to 150, and then New England or Hazy IPAs came on the scene. People go up to 200, 250 on those. But generally, if you're gonna go super high on sulfate, you don't really want to go too high on chloride if you want to have a little bit of a contrast. And then bicarbonate, less than 50 is good, but you most likely need to add acid or acidic malt to achieve this. Okay, so brewing water sources. So there was a question on the water profile on our website. It's true, I haven't updated it for this year. I think I last updated it last year. So it is out of date. However, if you compare year to year, Toronto water profiles usually vary by like 1 to 2 ppm from one year to the next on each of these. So you're definitely okay if you continue to use the one you already have. But that's a good reminder that I do need to go back to the city and ask for an updated profile. And sometimes I have to ping them twice to get an answer though. But for the most part, if you look at this water profile here, 35 calcium, 25, 26 for sulfate and chloride, alkalinity up to at 88, which converts to 107 bicarbonate, and then 9 and 14 magnesium and sodium. So this is pretty much what we've had for the last 8 years or 9 years I've been homebrewing. Hasn't really changed. These numbers are, so sometimes they'll go up and down by 1 or 2 ppm on each of these, but it's generally around here. So we haven't ruined your beer by not updating it, but we should update it. I agree. Okay, so water report input. So this year I added Brewfather and Brewin. I've tried to switch over to using Brewfather since I like their mobile app and I like seeing the charts with my my tilt. Though I was a Brewin user for many years, so I have them both in here still. So if you're going to put your water report into Brewin, it would look something like this. You put in the calcium, magnesium, sodium, and then you would go down here, put in your alkalinity from the water report, and then your estimated pH, and then it'll convert it to 106 or 107 bicarbonate, and then you put in sulfate and chloride. You can put in some of these other ones if you want, but they don't really affect the calculations in the software. Here is what Brewin looks like. Brewfather looks like when you put it in. So you want to add your water as a source water type in your Brewin water profiles. And then here's what it looks like when I was putting in my latest Toronto water profile. So you can see 33, 8, 12, 25, 26, 106. So all these numbers are a little bit different, but within 1 to 2 ppms. And I think even if you look at the Toronto water profile, they give mins, max, and averages. Even the mins and maxes are usually within 2 to 3 ppm of each other, which is really crazy stable compared to a lot of other places, especially California, where a lot of the brewing water knowledge comes from. John Palmer and Colin Kaminsky wrote the water book. They both live in California, and they both deal with crazy water profiles that shift throughout the year, where they shift from aquifers to surface water by week. So you hear some of the podcasts coming out of California, and it's crazy to hear them talk about how they have to like get a water kit and measure it every week the commercial breweries are measuring their water in-house every week, trying to figure out where things are at, and calling up their city on a weekly basis to ask which body of water their water source is coming from. So I think we're really, really privileged to be here in Toronto, and we have a pretty good idea where our water is coming from. Lake Ontario. Yeah, so water sources. So I guess maybe that was too early to say, but Lake Ontario is where our tap water comes from. All too often, I see some people give advice about how you should not use your tap water. You should go buy bottled water for brewing. And bottled water in Ontario is atrocious. Here's some pictures I snipped in the grocery store a few years ago of the bicarbonate levels of some of the bottled water that was being sold in like the large jugs. 341, 285. These all come from the really hard water areas of Ontario. And these are pretty bad to brew with. You need a lot of acid to counteract all this. And you're just fighting against yourself when we have really great water, tap water in Toronto and Mississauga and Durham and everywhere that pumps out from Lake Ontario. I think if you go a little further north, then they start to mix Toronto water with some well water. But I think for the most part, it's still deep water. But this is why this presentation is based off Toronto, because that's what I have experience with living in Toronto. But there's been some great conversations over the years on the Facebook group, people from outside of Toronto and asking and then sharing reports that they get and things. Yeah, yeah, Emily, I do this presentation hopefully isn't too hard for you to watch, living in Guelph now. But I'm sure you still make some fantastic beer. You just have to, I guess, play with the water a little bit more than when you were able to draw out of the tap. Yeah, so softened water is something I also get asked about quite a bit. So water softeners, they use salt to remove the hardness. So that means that you're subbing in a bunch of salt. So if you're going to do that, you'd probably be better off either buying RO or using your water straight with the full hardness and then trying to counteract it with acid and calcium. I think you'd end up with at least a beer that tasted not like salt then. But again, I don't have much experience doing that since all of my brewing experiences with Toronto tap water. All right, so that's brewing minerals. Mash pH is the other big piece of this. So what is pH? It's a chemistry term, it can be intimidating. So here's the most scientific I'll get in the whole presentation, I think. So pH is the concentration of hydrogen ions, and it's measured on an exponential scale. So 7 pH versus 14 pH, those are, even though they're, I guess, only 5 away, those are pretty massively different numbers. Yeah, so less pH, lower number is more acidic, and higher number is more basic or alkaline. So 7 pH is the middle of the range. So that's what pH is. That's pretty much all you need to know to be able to do brewing water chemistry. There's lots more that you can read about it with brewing water books, but I think if you know that, you can get away with the rest of the presentation. So just a few, I guess, benchmarks or reference points. So tap water, at least in Toronto, generally falls between 6.8 and 7.8 pH. And then when you add a bunch of grain and salt and acid into that, it drops. So that's how you get down to mash pH. Mash pH is generally recommended to be within a range of 5.2 to somewhere around 5.6. And then beer pH is further lower than that. So usually between 4.0 and 4.4, of course, ignoring sour beers, which are obviously down to like 3 or so, 3.2 or so. But fermentation is the next item that converts the pH lower. The yeast do drop the pH. Okay, so why do I care about mash pH? So mash pH, when it's in range, the hop bitterness is more pleasant, doesn't linger. You have improved break formation, so that means when you're boiling, the krausen formed in the kettle, it is improved. The enzymatic activity in the mash is increased as well. So you have these enzymes that are trying to convert all your starches into sugars. The activity of that is increased. And also you have a better chance of predicting your beer pH, so resulting in a crisper, fresher beer that shows more character. So I guess I had a note here, those things that I mentioned earlier about ATC and lower pH. So there's a reason we there's a reason why I say to cool it, and it's because convention in all the brewing textbooks is that this is measured at room temperature. So if you're measuring your pH at mash temperature using ATC and all that, it's going to read 0.2 to 0.35 lower. So if you're measuring 5.2 at mash temp, you're actually measuring like 5.4 or 5.5 at room temp. So keep that in mind if you decide to ignore my recommendations to cool it down with some ice. That you have to keep that in mind. Yeah. There's a really good Brewkaiser post that how pH affects brewing. I recommend reading that. I don't know how many folks still read have read Brewkaiser's wiki before, but it was really helpful when I started homebrewing. So mash pH. So it's a balancing act between the positive or the alkaline items in your beer and the acidic or negative or lower negative pH items in your beer. So water is a higher one, more alkaline, and then malts, the salts you add, the acids you add, all these things are more acidic. So that's how you get a mash pH in range by balancing these two groups of things. So highly alkaline water needs acid additions, usually lactic. Some people use phosphoric acid. I think I was going to switch to phosphoric at one point, but I decided to go back to lactic acid after hearing that some lactic acids can interfere with Brett fermentation. Not that I brew many Brett beers, but if I'm going to pick a process, I'm going to pick the one that's better for more things. A thinner mash usually means that you have a higher mash pH because you have more water. So if you're going to mash really thin, you might need to add more acid to get your mash pH in range. Calcium has a limited effect on mash pH. It does affect it, does lower it, but you shouldn't be planning to use calcium alone to get your mash pH in range. You should be planning to use acid as well, if that's necessary. Roasted and crystal malts are fairly acidic, and they will drop your pH much more than base malts. Anecdotally, whenever I brew a beer with a lot of crystal malts, my pH is always lower than I expect. All right, so I didn't used to talk about residual alkalinity, but people ask me about it a lot, so I put a slide in here to try and at least tackle it. I don't think this is an essential item to understand to be able to tackle water chemistry. A lot of brewing water presentations or textbooks focus a lot on this. And I don't think that's necessarily the right way to go, since it's kind of an intimidating term, or it can be. But yeah, so water chemistry info. So they describe it a lot, and I'm just describing it here for completeness. So like I said, so reminder, so hardness lowers your mash pH. So hardness refers to calcium or magnesium, and then alkalinity raises your mash pH. So residual alkalinity is the combined effect of these two things. So some people will say RA, residual alkalinity, and it's measured with the convention of calcium carbonate. So you're starting alkalinity, and then you subtract out the effect of the hardness. That's what this looks like, and that's your residual alkalinity. So if you have a RA of 0, then you're balanced. Positive RA means you're higher than distilled water. So DI mash pH is distilled water mash pH, and then negative RA is lower pH than if you had mashed that malt with distilled water. So hopefully that helps you understand the term if you come across it when you're doing further reading about residual alkalinity. But if you're wondering how this affects things, so a change in mash pH per unit of RA varies by mash thickness and grain. So if you're at 4 quarts per pound, about 25 ppm will result in 0.1, and then 50 at 2, and then 100 at 1. So thicker mash means more grain per amount of water. Okay, so that was a lot of info. I tried here to describe how I'm using all this info to do my brewing water chemistry. I see that I forgot to add Brewfather on here. So you can ignore this line that says I use Brew and Water. For the last 2 years, I've been using Brewfather instead. But Brew and Water does a great job. You just have to pay for it, and they'll send you the spreadsheet. But if you're already paying for Brewfather, I find it's decent. And it's all integrated together. I always was annoyed having to do Beersmith and then Brew and Water and then kind of retype everything in. So the first thing, what you're going to do, the first thing I do, I guess, is decide on a mineral profile. So I have a recipe in mind, and I kind of want to, the first thing I do is try to decide what impression I want. So overall, I always go for more than 50 parts per million calcium. but then I try to think, am I going to go for a balanced beer, a beer that I want to present more crisp and bitter, or a beer that I want to present more sweet and full? So that will kind of convert into the sulfate to chloride ratio that I start with. So often I start with the preset profiles as well. Brew and Water has some really good ones. Brew Father doesn't really have preset profiles in the same way. I just copied them over and re-entered them. So that's one way to do it. For the most part, I recommend you avoid historical water profiles. The ones that are out there are most likely pre-treated water profiles for those regions. So when you heard people talk about really, really hard water in Burton-on-Trent, those breweries are treating their water, either boiling or using some kind of chemistry process. So just keep in mind that when someone tells you that I'm Burtonizing my water, you don't need to go all the way to what the historical profile is advertised as, because that's probably not what the brewery is using. So you should. So my thought process is usually I'll hit enough acid to hit my desired mash pH once I've hit my mineral profile. So do the mineral profile first, and then don't try to use calcium to get down to your mash pH. So do your mineral profile, and then once you have the profile that you want, then you can go the rest of the way with acid addition. You can avoid adding alkalinity in dark beers by mashing thinner. So for example, if you want to brew a really dark beer, one way to raise your mash pH back up and counteract those dark malts is by hitting the other part of that group. So more water means thinner, means you can add more alkalinity that way. But you can also add alkalinity using baking soda. I don't recommend you use chalk though. I haven't seen a lot of recommendations lately, but over the years I've seen a lot of brewing textbooks say to use chalk for adding alkalinity, and that doesn't really dissolve very well. I've seen people try to dissolve it like under CO2 pressure, which just seems like a lot of work. Pickling lime is another one that people have talked about a lot for adding alkalinity, but I believe it's banned in Canada, so you won't be able to use it, at least not from a regular store. I know people buy it in the US and bring it home though.
Yeah, Eric, just a quick question on this might be a question more specific to like the Brew and Water users. How do you land on one of the preset water profiles? Is it sort of based on your knowledge of the style and also what you know based on your experiences with Brew and Water about what that profile is going to give you, or is it sort of both? Or
so the profile names are pretty good hints. So like they have yellow full, yellow dry, amber full, amber dry, and black full and black dry, and I think they have balanced ones for each of those as well. So that alone can get you a good way, but you also, I think part knowledge of the styles is the other part, to know how you want the beer to present. If you're going to brew an IPA, you probably want the bitterness, or at least a traditional IPA, you probably want the bitterness to present itself a little bit more than if you were brewing, say, like a light lager. So in that case, you'd probably want to go for the sulfate to chloride ratio that would expose the bitterness or the crispness more than the fullness. Then you go the other way for something that you want to present a little sweeter and fuller. So like these three here, balanced, crisp, bitter, sweet, full. So you can kind of go from there and from looking at the Brew and Water profile names. Okay. So some other pieces of my approach just to help put it together. So lactic acid is what I generally use instead of acid malt. Acid malt is something that exists, but I prefer not to adjust my water profile with something that also adjusts my malt recipe ratios, because it's really annoying to have to mess with the percentages when you're just trying to add some acid. Yeah, and I mentioned earlier that phosphoric acid can inhibit Brett fermentation, so that's why I kind of have moved away from using that. For the most part, my approach is to aim for 5.2 in pretty much all cases, but when I measure, if it's somewhere around 5.4, I'm happy with that, and I don't try to adjust from there. If it's like 5.6 or above, I'll probably add some more acid to get it back down. But that is something that you should expect. So whatever you calculate in the software probably isn't what you're actually going to measure. They will usually differ a little bit. At least in Toronto water, my experience is that it usually is a little high compared to your calculated. a side note is that some people prefer their darker beers at a slightly higher pH than their lighter beers. So you can keep that in mind when trying to come up with your recipes. So I recommend that you adjust. So you may have to adjust after you measure your pH. And I mentioned that it doesn't. So the current models out there that are calculating the expected mash pH, they don't really have a model of the different grains of the same color. For the most part, it's just like, I think base malt, and then maybe like an adjunct like oats or rice or corn, and then crystal and roast. So if you put two totally different malts created through totally different processes, but they fall in the same category, the same color, the software will treat them the same, even though they will probably have a different effect. So you should keep that in mind, that this thing is all estimates, not perfect. Yeah. But usually for me, I end up adding a little bit more acid after measuring. And then that way, you know, for your next time you brew that beer, right? If you write down that your measured mash pH first time and then your adjusted mash pH, you'll know if you're going to brew that recipe again or something really similar, you have a little bit better knowledge about where it will actually end up based on what the estimate is and what you measured last time. So my rule of thumb is if I want to adjust it on the fly, I'll add 1 or 1.5 milliliters of lactic acid for every 0.1 pH I'm above my desired pH target, and that's in a 5-gallon batch using Toronto water. So I mentioned an example. So if I'm expecting 5.2, I measured 5.45, and I'm feeling finicky that day, and I really want to get it down below 5.4. I'll add maybe 3 milliliters of acid, hoping to get back down to 5.2, and there you go. This was a real world example, and I measured 5.26 after that. And then you record that and use it next time. Okay, so I think there's a few questions that have built up. Is there anything that I should address now? What if it's lower than 5.2? So in theory, you could adjust with baking soda to bring it back up. For the most part, I don't do that. I just note it down and proceed. And often the beer turns out fine anyways. I think one example of where my mash pH was way too low was I brewed a Doppelbock. I think it was like 10 or 15% crystal malt or something crazy, Munich or something, and it was like 4.9. And I was all worried that the beer was going to be terrible, and it turned out fantastic and still won awards. So I think don't worry too much if you're off. Just use that knowledge to inform you for next time that with your water and that type of recipe, even though the software estimated 5.2 and you hit 4.9, that you should probably not trust it as much and maybe aim for 5.4 or 5.45, 5.45 or something. So do I measure mash pH right away or wait for it to settle? So I always wait for about 10 minutes. So I mash in, mix everything together, measure the mash pH, measure the mash temperature to see where I ended up. And then I'll usually wait about 10 minutes. And normally during that time, I get out the meter, I put it in the calibration solution, I go upstairs, get some ice, fill my little bowl. And by the time I do all that, it's usually been almost 10 minutes and can take a sample. I don't see any question marks in the other comments. So I'll move on. And if I missed your question, bring it back up at the end. Okay. All right. So when John Palmer was here for Brew Slam 2019, someone told him that I had a water presentation that I did every year, and he came up to me and said, "Hey, Eric, do you have my brew cube in your presentation?" So right after that, when I did this presentation in 2020, I added the brew cube so that I could say yes next time John Palmer asks me. But it is a really handy way to visualize how things kind of play off each other. So you can see here that each of the axes is measured, and kind of you're supposed to play things off the opposite side. So helps you visualize how the elements of the beer affect the target water profile. So the beer flavor, so there's one here that says beer flavor corresponds to sulfate to chloride ratio. So if you cross across the cube and down, so you can follow the line, you'll see sulfate to chloride ratio. Beer color corresponds to residual alkalinity. So if you look here, beer color, you cross across the cube, corresponds to residual alkalinity. So darker beer means you have more residual alkalinity, plus 100. And then beer structure, so that's the bottom part here. So if you cross across the cube, it corresponds to calcium, which is your mineral structure or your your seasoning level. So more calcium means a higher seasoning level, which results in a firmer structure, as John Palmer calls it. So if you've seen this cube before in How to Brew and you're trying to figure out what it means, this is what it means. Okay, so I have a few quick examples to help hopefully tie this all together. So one example here, American Porter. So this is an example using Brew and water. I showed the water profile entry before. So this is the recipe. You put it in like this. So I think it was 9 pounds of Maris Otter, 1.5 pounds of Munich, and then some crystal, chocolate malt and black patent. Put that all together. I just simply selected a black full profile since it's a porter, and I wanted it to be somewhat full and somewhat sweet presenting. So I just selected that, and then you can see this is the profile that was entered on the first page. And then this was the water adjustments that I ended up calculating for minerals. So I want it to be a little more full. So I used calcium chloride and then a little less gypsum. So here's a snapshot of the next page of the Brew and water spreadsheet. So you can see here the 0.1 and the 0.2 and the overall finished water profile with those adjustments. 61 calcium, 9, I think that's sodium, 14 magnesium, 41 sulfate, and 59 chloride. Would be really handy if I could get a big enough monitor at the time to snapshot the top columns. But then you can see here I put a big red box to say that for American Porter on my recipe on my system, I know that I probably don't need to add any lactic acid and my pH will still be in range. So 5.17 here, you can see it's already estimating that. So the adjustment summary page to show just the resulting numbers, including the sulfate to chloride ratio of 0.7. Okay, so here's the same adjustment done on Brewfather, and it fits on one page, which is really nice. So here's the recipe. So it should be exactly the same or really similar. I think this is a newer version of the recipe since that was a really old screenshot. You can see the target water profile. I just entered the black full from Brew and Water has a target profile for Brewfather. And unfortunately, the thing I don't like about how Brewfather does this is with Brew and Water, you kind of do per gallon adjustments. And with Brewfather, you kind of have to account for the total volume in the numbers that you put in. I don't know if there's a way to change that. I'm sure if someone knows, they'll tell me. But yeah, so you have to account for the total volume. So the numbers are of 0.1 and 0.2 don't match 1-to-1, but multiply by the batch size, I think is like 6, or maybe this was a 10-gallon batch or something. And then you can see the resulting water profiles somewhat close, a little bit higher than the target profile. All right, do you ever add salts to the kettle? I generally don't. Then again, for the most part, I'm doing no sparge brewing, so I don't add anything. I don't have any sparge water. I usually add everything to the kettle, or to the mash. And usually I add the minerals before mashing as well. So that's an example of a porter. Totally opposite end of the spectrum would be a Helles. So a little bit of Pilsner malt, some Vienna, a middle of the road water to grist ratio. So this one's not a no sparge. So maybe like 3 3/3 gallons of water, and then 5 and a bit of sparge. And then for this one, you kind of set your water goal. So low seasoning, a little bit saltate forward to make it crisp. Since it's a Helles, we want it to be nice and refreshing. So the resulting additions look something like this. So 0.7 grams strike and 1.1. So same amount per gallon, just scaled based on the water that goes into each of those steps. Calcium chloride and then gypsum. And then since this is a lighter colored beer with Toronto water, we need a little bit of acid to get in range. So the resulting of 54, 57, and you can see chloride is much lower. And then the overall seasoning level is just above 50. So it's on the lighter end. And then I don't remember if this was a measured or estimated mash pH. I hope it was measured, but I don't remember that for sure. And then a final example, another opposite end of I guess brewing spectrum would be England Ipa. So a bunch of two-row, a good amount of oats, a good amount of wheat. This would be a no sparge batch, and a pretty big amount of water in the strike since it's no sparge. And then New England, or I guess has their soon to be renamed Hazy IPA, is very chloride forward, very high seasoning level, so usually around 0.5, but higher seasoning level. 3.6 grams of sulfate, 7.8 grams of chloride, and then 5.2 milliliters of lactic acid. So this results in about 129 ppm of calcium, and then 152 ppm of chloride, and then half that for sulfate. So this one does have estimated and measured. So this is a lighter colored beer. In my experience with Toronto Water, lighter colored beers usually measure a couple points higher than estimated. So in this case, I added 2 milliliters of acid to get back down closer and got down to 5.26. So those are my 3 examples and my approach. And I have some further reading here from things that have helped me over the years. So I'd recommend checking those out. Though for the pH meter guide, I still recommend not following some of the US sources, since we have different availability here compared to some of the US based pH meter guides. So that's what I have. Let's see what we have for questions. Never understood the reason for mash and sparge being different in brewing water. Is the pH thing or mineral? So when you say mash and sparge water being different, do you mean being treated separately, or do you mean having different water profile targets for your mash?
Well, when you dial in some of your additions, it says not recommended for sparge, only for mash, including acid additions and so on. Acid additions, and specifically, it says go off and do it differently, and I never understood why it should be different.
So why you shouldn't add acid to your sparge and add it to your mash?
Or it sends you off to a different calculator, but some other items too, it says not recommended in sparge. And I know that we add certain minerals to our mash for mash health, which we don't really need in the sparge, but it's never been clear to me exactly what the science is.
Personally, I try to match them. So I haven't come across this warning.
Yeah, okay. I was just
my thought process is whatever I put in, I want, if I'm going to add a bunch more water, and I don't want it to change the profile that I've already set. So I think I have the same approach as you do.
Yeah, and I'll be honest, I've been probably using a 5-year-old version of spreadsheet because it's continued to work for me, and I didn't want to reload a new one.
Strong bases. Which one would be considered a strong base? I assume not baking soda. Okay, I don't know. Luke, do you know which things?
If I jump on it, baking soda is included in it, but it's basically just anything that would raise your mash pH. They don't recommend, or he doesn't recommend putting in your sparge water.
Makes sense.
Or not raise your mash, but raise your sparge pH.
I mean, for the most part, you're gonna have water. It's gonna be 7 something. So there's no reason to make it higher before you're just about to try and have yeast drop it way lower. So that kind of makes sense. But I can see how it can be confusing if you're trying to match 1-to-1. All right, would you add anything other than gypsum and calcium chloride to RO water? I've heard that yeast requires other minerals. I probably would add a little bit of something to make up some sodium and magnesium. I think there are some other ways to do that, though I don't have a ton of experience with RO water since everything is with tap water. Though I suppose table salt or would be a good way to add sodium. Magnesium, I guess you could use Epsom salt, but probably don't need to. Yeah, so someone mentioned yeast nutrient. I definitely recommend using some yeast nutrient in your boil. I didn't include that in a water chemistry presentation, but yeast nutrient all the way. If you haven't checked out the escarpment yeast lightning, you should do that. Are there any other questions that I just glossed over as I watched the text scroll by? If anyone asked a question that I missed, feel free to type it again or raise your hand or something. See if I can see the participants list come up.
There's another question about Epsom salts that just came in.
Why did I not using Epsom salts? Isn't Epsom salts magnesium bicarbonate? Or am I mistaken?
Magnesium sulfate.
Oh, magnesium sulfate. Okay. I mean, so magnesium is not a great way to add hardness. Like adding calcium and magnesium is usually intended to add hardness, which I think magnesium has a much lower effect than calcium does. So I think that's probably why I don't recommend it. Overall, though, I'm trying to keep things simple with my water approach. If I have 4 different salts that I have to balance with each other, then the balancing act just gets a lot more complicated. So for the most part, I keep big bags of calcium chloride and calcium sulfate around. Luke says, I suspect the answer on why the acid calculator is separate for sparging is because it assumes you don't have the same amount of phytic acid formation in your sparge. Okay. Yeah, because like there's definitely once you're done mashing, the chemistry that's going on in a mash is obviously not going to happen to that same water that you put in sparge. Makes sense. Has anyone not done water chemistry before, and this presentation did not help them move closer towards that? And do they have any questions that I could help answer? Has everyone done water chemistry in their beer?
I do for some reason. I've been doing water chemistry for the past handful of years, but for some reason, I always kind of just wing it. So I go by the calculations and I just assume it's right, even though I have a pH meter and everything. It's just like the pH meter and measuring it is just that much more work, especially with the kids are running around and everything. I will say that I kind of go by the calculations and hope for the best, let's say.
I mean, one way that you can do this, and I've seen people do, is rely on the experience of others using the same water profile and ingredients that you have, right? So I can tell you that from my experience with Toronto Water, with the way I mash, usually the calculated number is a few points lower, a few decimal points lower than what I actually measure. So if you're brewing a bunch of lighter colored beers and you're always estimating 5.2, maybe bump that down a point or two if you really want to be close to it. But if your beers are turning out fine how they are, you're probably okay anyways.
I think this presentation is a good reminder. I should stop being lazy and just get the pH meter that I have and measure it.
I mean, to me, the pH meter is a lot of fun because I feel like I'm being a mad scientist in my basement. I like using pH meters because it feels good to measure that number, and when you hit it, it's a nice little good feeling.
Are there any other questions for Eric on an excellent and updated water chemistry presentation?
Oh, Daryl says he asked one 4 messages up.
Oh, there it is. I sometimes wonder whether it matters batch adding minerals and acid or splitting it and adding it separate thoughts. So in other words, adding all the minerals to, instead of splitting it up between mash and sparge, just adding it all to the mash or adding it all to the sparge for that matter.
So I guess like one of the things that you should keep in mind is that like we're trying to hit a target in the mash pH in the mash process. So if you're adding all these things to hit your mash pH, that's fine. You can hope that the beer pH will work out because the yeast is usually a good equalizer. But if you're going to add a bunch of water without adding anything else to it, then your finished pH and your finished profile will be different than maybe you would have expected when you're calculating your mash water profile. So if you calculate your mash water profile to be like a black full and then you add a bunch of water to it, it's going to be a diluted black full, I guess. But the chemistry and the process behind that will probably still work the same effectiveness as because you hit your mash pH and then your yeast will probably take it back down the rest of the way.
If you don't mind, I can throw in a little bit of knowledge here. If your sparge pH gets too high, you can extract astringency from your husks. So you want to keep that mashed, your sparge water lower to prevent astringency coming from your husks. So that's one of the reasons why you do a mineral change for your sparge water.
Yeah, I'm just wondering because sometimes I add like I use Brewing water, so sometimes it says like what to add to your mash, what to add to your sparge, but I also brew on a robo brew, so I kind of like to get as much done the night before as I can. So sometimes I mix 100% of my minerals and 100% of my acid just in the robo brew the night before, and then I split it once it's warm in the morning, right? And I just wonder like if it matters like doing it that way versus like splitting it in the morning and then adding all my minerals after, which would like take me more time. But
Are you undershooting your mash pH somehow by adding everything in one half of the water?
no, it all works out. I just like usually I check my mash pH. It usually works okay. It's just kind of something I've always wondered about whether it matters, but it doesn't seem to affect mash pH, so it hasn't shown me that it doesn't really work doing it that way. But
I mean, beer. Like, if I've learned anything over the last 8 years of watching like all these experiments go on, that you can do a lot of stuff to your beer that isn't conventionally okay and have it turn out the same. So
I just try to have as much done, the night before, so when I wake up, it's all ready to go, right? So it's kind of one of those things I've been doing to kind of just like streamline my process a little bit, but it doesn't seem to have a negative effect.
So if anything, you're recommending it, sounds like.
Yeah, I don't officially endorse or recommend any of my processes for other people, but your results may vary.
I guess maybe I'll reply to the one about extracting astringency from husks. I think that's definitely conventional. That's definitely recommended as conventional wisdom. But I think I've seen so many people do these brewosophy experiments over the years, and my memory is every one of those people haven't been able to tell the difference between like a crazy high mash sparge pH and a normal one. So I mean, that's no reason to sabotage yourself. But I try not to worry about that since I've seen so many people get away without it. But that being said, I still add acid to my sparge water when I'm doing fly sparge because it's conventional wisdom, and that's how these things are built, and it doesn't hurt me at all to do it. So plus it feels good to follow the recommended processes. So you have one less thing to blame when the beer doesn't turn out how you want, because that's always the line of questioning when how come this beer didn't turn out the way I was hoping it would, and then you start to think about what your process was, and the less you deviate from the conventionally recommended ways, the less things you have to point at. So I'm not poo-pooing any following the acid and sparge water. I just don't think it's as much of a vector as I used to think. But thank you for chiming in. I don't mean to attack you or anything at all like that. I promise.
Just attack.
If there's no other questions, somebody's got one.
I have a question. It's Ian. How you doing?
Hey,
I can't figure out how to put the hand up. I'm not on here. I have a question. So when we had the guys from Third Moon on, they were talking double mash, and I've talked a lot to David because I did a couple over the holidays.
Yeah.
A little post-traumatic stress over that. But I just have I'm just wondering, I don't know if it's not really part of your presentation, but just if you've ever read anything about like, how do you go about, doing your water chemistry when your second mash is with, like when you're doing a double mash? Like, any thoughts on that?
Well, I don't think Brewing Water or Brewfather or any of these calculations
are going to help you.
Are going to help you with that.
Yeah,
you probably want to at least measure extra well and extra points as you go through that process, and at least you'll know for next time. But I mean, if I think about it, you're going to be using essentially strike water, or I guess sparge water. I guess strike water. You're going to be using strike water that has a pH of like 5 point something. So adding a bunch more minerals and acids to that probably isn't going to get you in the same range as adding a bunch, because you're going to be adding a bunch more malt to that already, right? So
Yeah.
My first approach to it probably wouldn't be to add all the same minerals and acids all over again. I would probably not add things on the second run through, or maybe even add a little less on the first run through, keeping in mind that you're going to be adding more malt again later.
Yeah, it's complicated. Yeah, there's not a lot out there. That's why I thought I'd ask. But David and I had talked, and I think this is what David did. It's what I did the second time I did it. Was I basically figured out figured out a mash profile for the first mash, and then figured out and kind of used that, like those totals, as what I had for the second one, and tried to come out with the same thing. So it was less of everything in the second match, but I don't know if that makes any sense, but I'm tired. But yeah, it's all right. It just got confusing now. I'm still confused thinking about it. All right.
Have you done one now? So, or you did one over the holidays, and that's why you're mentioning it?
Because it needs a little bit of time, but it was fairly big. It was a starting graph, like 1.124. So it needs some time to rest. We'll see what happens. I hope it turns out okay.
Yeah, I after talking with Ian about this for a little bit, I kind of explained what I did using Brewfather, and I created a profile, a recipe based on the first mash, and it spit out, what the pH was going to be, and what the chemicals were, etc. Because Brewfather will spit out the, here's based on the chemicals you're adding and your grains and acid, etc. Here's your chemical profile, right? And then I just took that chemical profile and I created another profile in a second recipe in Brewfather for the second mash, right? So then I use that profile as my starting water, right? And you can't see my hands, but I'm using air quotes, my starting water, right? And basically, when you add your grains to that, it will then adjust that profile again. Like Eric said, it's basically you're starting with strike water that's in the 5.3, 5.4, I guess, depending on the type of beer you're brewing, right? And if it's an imperial stout, like 5.4 or whatever it is. And usually you don't have to add as many chemicals in the second round.
Probably none.
Yeah, very few, very, very few, right? So, but
all right, thanks. Thought I put it out there. Still some. I'll figure out how it goes.
yeah, it's a good that discussion. I see Daryl is talking about it as a presentation idea. It is interesting, and I know in talking to yourself, Ian, about it, between the two of us, I think I wouldn't say we figured it out, but we've kind of come to realizations that we probably wouldn't have gotten on our own without talking to each other, sort of thing. So
yeah.
Anyway,
it's good to have a support group.
Yeah. Anyway, that's neither here nor there with respect to the water, but it is a good question, right? So, any other questions for anybody? If not, I'm going to stop the recording. I'm going to say thank you to Eric for presenting, and we will get around to updating that page.
After my public shaming.
yeah, we will. I promise. So, thanks, Eric, and hopefully, if this, I know this is a yearly thing, so hopefully next year it'll be even, I won't say even better than it already is, because you've added to it already and you've changed some stuff, and which is good. So
this time we have a recording of the people telling me and me saying I should add that.
Yeah,
Instead of me saying I should add that and then not writing it down.
yeah, true enough. So I'm gonna stop the recording now.